Okay, today's video is 12-7, graphing trigonometric functions, and we are going to be going through all 6 of the basic trig functions with very minimal transformations to them. We'll get into more difficult transformations in the next section. If you want a copy of the note sheet that I'm using to go along with this video, then there's a link in the description that you can use. Okay. So to start off with, what I have on the note sheet, I put all of the parent functions together so you'd have them in one place. So I kind of scroll back and forth to different pages I'm going to do a few of the parent functions, and I'm going to do some examples and go back to parent functions and then 2 examples. So just so you have a heads up of what's happening. All right, so the first one that I'm going to discuss is our cosine function. Okay. And to figure out how to put this on the graph, have your unit circle handy if you don't already know these values. But basically, you can always graph anything by making a very simple t-chart. So I have x and y, and I start at 0. So if I plug in 0 into this equation, the cosine of 0, of course, is 1. And on my unit circle, or when I plug in points, I'm going to plug in the ones that are easy to calculate, which means I'm going to what we call our quadrantal angles, those angles that are on the axes. So 0 is 1. If I go up to pi over 2, the cosine of pi over 2 is 0. Actually, and I'm going to go ahead and plot this point so I do it. So at 0, I'm going to go to 1. At pi over 2, which is halfway between 0 and pi, it's 0. And then I'm going to go to pi. Cosine of pi is -1. Then I'm going to go to 3 pi over 2. Cosine of 3 pi over 2 is 0, which is right here. And then 2 pi. Cosine of 2 pi is back to 1, which is right here. So if you haven't figured out by now, if I keep going around the circle, then you're going to see that there is a pattern, and these are going to be the values. And of course, you can graph everything in between to figure out what's happening if you need to. But I'm going to tell you that if you do, you'll find out that it's going to look like this when you connect all the points. So that is the graph of our cosine function. Now, from looking at that graph, you should be able to tell me that the domain is all real numbers. And my range, okay, what is the lowest point on my graph, which is what we call the min? That, of course, is -1, and it's equal to -1. And what is the max on my graph? That is 1, and it's equal to 1. So we have a bracket. Okay, I'm going to come back to these two later. So next I want to go talk about the sine function. So in a similar fashion, that's not what I wanted to do. All right, in a similar fashion, I'm going to make that t-chart, and I'm basically just making this so you can understand where these points are coming from. Okay, sine of 0 is 0. The sine of pi over 2 is 1. The sine of pi is 0. The sine of 3 pi over 2 is -1. And the sine of 2 pi is 0. Again, we have gone through the whole thing, and if I continue to, excuse me, that's not where that goes. If I continue around my unit circle, you're going to see that the points will continue in this fashion, and they will repeat. So this one is going to look like this. And importantly, I want you to know, I did that, I know why I did that, is that it does go on forever and ever in both directions, okay? Now, again, what's my domain? -infinity to positive infinity, and the range is, again, -1 to 1. Okay. So, some important things that we want to talk about on this graph. I got to turn to page 2. So, on the next page of your note sheet. Okay, because all those above there, in between there, are the, like I said, the parent functions. Okay, so these graphs go on forever and ever. And they all have what we call an amplitude, a period, and a frequency. So I'm going to talk about what those things are. Not where I want to go. Amplitude. Amplitude is defined as 1/2 the difference of the max and the min. Kind of an easy way to remember that, max and min. If you prefer it in formula format, that would be the max minus the min divided by 2. And I want you to pay attention to, if I start with a max and I subtract a min, then I hope you'll remember that this number, or your amplitude, is always positive. Because if I'm taking a bigger number and subtracting a smaller number, then there's no way for this thing to be negative. Okay? The next thing we have is something called the period, and the period is the horizontal length of one cycle, of a cycle. Okay? There's no set formula to figure that out. It is denoted by the letter P. Okay? But all of these functions that we are going to be graphing with all the trig functions are periodic. Okay, and what's happening there, if you notice when I went to, so we'll come back and keep talking about the period. Let me go define frequency and then we'll go back to our graphs because that'll be easier for you to understand. Okay, the frequency is the number of cycles in a given unit of time. That didn't come out right. All right, and you can find that frequency by just taking the reciprocal of your period. Okay, so going back to the period, I want to go back to the graphs that we were just talking about. Okay, so we've got our cosine and our sine. So the period, okay, is, if you notice, this right here was how long it took for it to repeat. I started up here at a max, and then I went back to a max, and then I'm going to do the same thing over and over again. So a period is the horizontal length of one cycle. How long did it take before it started repeating the values? And that's 2 pi. Okay, my amplitude, as we said, is the max. What's the max of my graph? 1. And the min of my graph is -1. And if I subtract those and divide by 2, I will find that my amplitude is 1. Okay, now my sine graph, period again, okay, how long it took when I made this chart. Or now this is just so you don't get confused. I can go from a max to a max to figure out a period. I can go from a min to a min to figure out a period. I can go from a 0 to a 0. And so you might question why it's not just right here. So when you think about it, you have to get the same y value going in the same direction. So what does that really mean? When you start here at 0, and where's the next 0? Well, it's here, but that y value from there is going down, and this one's going up. So I got to keep going and find the next 0, which is right here. So that's why my period is from 0 to 2 pi again. Okay, so now I want to go back and we're going to go graph some and see what kind of changes we're going to have with our graphs. Okay, so here is our equation. Okay, we have y equals a times the cosine of bx, or y equals a times the sine of bx. Okay, when you have that, the number in front of your trig function is your amplitude. But so you remember it's always positive, think about that as the absolute value. Okay, and your period is the period of your parent function, which in this case is 2 pi divided by b. And again, if you need to put absolute values, a period is a horizontal length. The length can't be negative. So whether b is positive or negative, you're going to just divide by the number. All right, so let's go do some examples so you can understand how easy these things are to graph. So the first one says y equals cosine of 2 theta. Theta is the same thing as x. So this is my theta, This is my y. Okay, so whenever you're graphing trig functions, you're always going to have to find the period, and you're going to need to know what that a value is. So a in this case is 2. My period is 2 pi over b. Well, b is 1 because that's the coefficient of my theta, so it's just 2 pi. Now when you graph, you want to go out 4 tick marks from your origin, 1, 2, 3, 4, and label it 2 pi. Halfway between is pi. Then I just want you to label every other axis. You can label them all if you want to, but I'm going to do just every other one, which I'm going to get this one, by adding, well, thank you, by adding these two together. You always get that one by adding those two together. This one's going to be the negative, the opposite value of that. So I've labeled my x or theta axis, and if this goes by anything but ones, then you have to label it. If you're going by ones, you don't have to label it. Okay, so the next thing you got to figure out is, what does the cosine curve look like? Okay, I hate to switch back and forth, but I want to go back and just refer you back to this. That's my period, my initial period. So you're going to hear me say a lot, the cosine, yes, it starts at 1 here, but basically you want to think of that as a max, and that's going to be determined by whatever your amplitude is. The other thing that I refer to a lot is the midline, and that's going to come in helpful when we start moving them. Okay, your midline, your amplitude tells you that you go that much above the midline and below the midline. Okay, but more importantly, when you start graphing, we always start and end one period at the same place. So I'm always going to ask, where does the cosine start? Cosine starts at a max. The sine starts at a 0. So think about that as you're going through, or you're going to hear me talking about it a lot. Get a little repetitive, wondering why I'm saying that all the time. Okay, so cosine function starts at a max. My max in this case is 2. So I'm starting at 2. I'm going to go to the end of my period, and this kind of helps me not get lost in all these tick marks and be consistent. Halfway between the two maxes is a min, and halfway between each max and min is a 0. And now I have a pattern I'm going to keep and be consistent, because what you're going to have to do on your quiz and test is graph 2 cycles, or fill up the graph, but more importantly, I want to be able to see 2 cycles. I just think it shows a better understanding of the graphs itself. So now, the other thing I need to tell you is when you're connecting it, do not draw your graph like this. Okay, why do I not draw it like this? Because this is a minimum, and if you draw it like this and put an arrow on it, he doesn't like that arrow, whatever. If you put an arrow on it like that, then you're not telling me what the max is. Okay, so I'm going to go take that away and draw it correctly. So if that's the minimum, then make sure you curve back around so I know that you know that's the minimum value of our graph. And I do want to see arrows on your graph because these functions go on forever and ever in both directions. Okay, let's go fill in our domain. Domain is negative infinity to positive infinity. And my range is, changed, but now we are negative 2 to positive 2. Okay? All right, let's look at the next one, the sine curve. Okay, first thing I'm going to do is find my period. My period this time is 2 pi over b. This is my b right here. That's 2 pi over 2, and that, of course, is pi. So I'm going to go out 1, 2, 3, 4 tick marks, label it pi. Half of pi is pi over 2. To get the third one, add these two together. That gives you 3 pi over 2. And on the other side is the opposite. Okay? My amplitude, a value is 1. Okay, I don't know where that went, why it went there. Go away. A is 1. So I'm going to go by ones again, and now I'm ready to graph. My sine curve, my sine starts at a 0, ends at a 0. So 4 tick marks later, I'm putting the same thing. Halfway between these two zeros is a 0. And then halfway between the first two zeros is a max, and halfway between the last two is a min. So where am I getting those points? Again, from that parent function that we put and we did at the very beginning. And then I'm just have to fill up my graph so I can get 2 complete cycles. Okay? And then we're going to connect them. The other thing you do want to make sure you know is that this is a curve. So there shouldn't be any kind of straight, anyway, that didn't want to make an arrow for me. Okay, any kind of straightness to it. Okay, domain, negative infinity, positive infinity, range, -1 to 1. Okay, all right, one more example. So basically what I did here is I did one example with change in A, one with a change in B, and now I'm going to do one, which is on the next page for me, of 2 changes. All right, so same process. First thing I'm going to do is find that period. 2 pi over B. This is my A. This is my B. 2 pi over 2, which is pi. So I'm going to go out 4 tick marks. 1, 2, 3, 4, and label it to my period. Half of my period is pi over 2. Add them together, and I get 3 pi over 2. Other side is the opposite. Now, on these graphs, you're in charge of it. This is what my algebra teacher, she used to draw the graph and then go back and label the axes, okay? But more importantly, you're in charge of the scale. So you can put 3 wherever you want to. If you want to put it up here, you can put it up here. But to make life easy, I'm just going to label that one 3 and -3. So now I'm ready to graph. I got to remember my cosine starts at a max. So I'm starting at a max. 4 tick marks later, I'm ending at a max. Halfway between, I am at a min. Halfway between a max and min are my zeros. And then I fill up that pattern. And let's see. So this is my min. So it looks like this. Okay, and domain and range. Domain again, negative infinity to positive infinity. And the range is -3 to +3. Okay, now we're going to go back and talk about the secant and the cosecant. Now, why am I choosing those next? Because they're so closely tied to these 2 graphs here. Okay, so the next one that I have is the secant graph. So I'm going to go back and I'm going to kind of keep them. You're going to see how they're all tied together. All right, so my secant graph, if you remember, it's 1 over the cosine, okay? Then it has the same key points as the cosine function, which means that I started at a max, I ended at a max, halfway between was a min, and halfway between the max and min are zeros. So I'm going to fill up the graph as if I am drawing the cosine curve. But before I connect them now, I'm always going to look and see, am I graphing the cosine or am I graphing the secant? And if I'm graphing the secant, which we are doing right now, we're graphing the secant function, that's 1 over the cosine, which means I have a problem whenever the cosine equals, yep, you said it, 0. So everywhere you have a 0, you actually have an asymptote because your graph is undefined. I just realized this thing has nice lines to do, but anyway. Okay, now I can talk about it more if you want to, but what's happening here, if you think about if this were my cosine curve going like this value would be 1/2. So when I take the reciprocal of that, which is 1 over 1/2, I'm going to be at 2. So if you do all of these, you're going to see that these are going to be what we call, you can call them parabolas, approaching the asymptotes, and they always go away from your midline. Midline's that same thing where it happens the same thing above and below it. Okay, so domain's a little bit trickier. And when you're trying to figure out the domain with anything that has asymptotes, I think you'll find it easiest if you label them. So this is pi over 2, This is 3 pi over 2. This is 5 pi over 2. If you have any trouble with this one, you add up the 2 around it and divide by 2. So 2 pi plus 3 pi is 5 pi divided by 2. Okay, so I got to name all these. This, of course, is negative pi over 2. So if I'm trying to name those, we're going to say it's all real numbers, except x cannot be. Now, if it starts on 0, pretty easy, but it doesn't start on 0. It starts, we're going to act like it starts at pi over 2. Really doesn't matter which one of these I start with. But then you need to figure out how far apart they are. So basically, I'm subtracting 3 pi minus pi is 2 pi over 2, which is pi. And so it's plus pi n being any integer. So if I start here and I add 1 pi, I'm there. If I add 2 pi, I'm here. If I subtract a pi, I'm over there. So that's how we write the domain. The range, I told them in class they could write it one of 3 ways. I happen to think the shortest way is for you to remember your absolute values. And the absolute value of y is greater than or equal to 1. Now, you could also say y is greater than 1 or y is less than, actually it's supposed to be equal to, negative 1. You could also use interval notation, negative infinity to 1. Actually, excuse me, negative infinity to negative 1, union 1 to infinity. Okay? So you've got those possibilities. All right, let's go talk about the cosecant. The cosecant is, of course, 1 over the sine function. So that means I'm going to take all those key points from my sine graph. Sine started at 0, ended 4 tick marks later at 0. Halfway between was 0. Halfway between the first 2, I went up, and halfway between the last 2 went down to a min. Again, continue the pattern to fill up your graph. It will just help your understanding. And just like we had with our secant, anywhere that the sine is 0, I can't have 0 in the denominator, I'm going to have an asymptote. So these are my asymptotes. And I'm going to graph them, and the parabolas away from my midline, always away from the midline. So it's looking like this. So thinking about, it does contain those points, so those points are common to both because, of course, the reciprocal of 1 is 1. My domain, all reals, except x cannot be what numbers? This is 0. These are multiples of pi. And since it starts at 0, I can just say those are multiples of pi. So we're good to go. My range, same thing we had on the secant function. Absolute value of y is greater than or equal to 1. Oh, poo. I didn't do the domain. I mean the period and amplitude. Period and amplitude is going to be the same as your parent function of the cosine. So the period is 2 pi. Amplitude is not 1. Because amplitude, remember, is defined as max minus the min. Well, what's the max of my graph? There is no max. Okay, so it's NA. For here, period is still 2 pi. Amplitude, not applicable, none. Choose whichever word you like best. Okay, so let's go do some examples of those. Same kind of changes that we talked about. So I'm going to go do y equals 2 times the cosecant of theta. All right, let's go here. All right, so again, I'm starting with my period. My period is 2 pi, well, 2 pi over 1, which of course is 2 pi. The A value is 2, but remember it's not amplitude because we don't have an amplitude with these graphs. Okay, and so before, period 2 pi, go out 4 tick marks, label it 2 pi, halfway between is half of that. To get the last one, I'm going to add those 2 together. On the other side is the opposite. Okay, my A value is 2, so I'm going to label my graph 2 and negative 2. And now I'm ready to plot points. So now I have to go figure out what is the cosecant, the reciprocal of. And it is the reciprocal of the sine. They never start with the same letter. And so my sine graph starts at a 0. So I'm going to go put those key points. Starts at a 0, ends at a 0. Halfway between is a 0. Halfway between the first two is a max. Halfway between the last two is a min. And then I continue the pattern. Okay? And before I connect it, I'm going to remember that I cannot have 0. Wherever it's a 0, I have an asymptote. Okay, and now I'm going to go graph those away from my midlines. So I'm going to go as such. Okay, and now let's go back and label our domain. Our domain is all real numbers. X cannot be, well, that's 0, pi, 2 pi, 3 pi. So that's going to be multiples of pi, pi n. My range is absolute value of all real numbers, excuse me. All real numbers, the absolute value of y is greater than or equal to, it's not 1 this time, but it's actually 2. Okay? So that's a cosecant. Let's look down here at a secant. So let's go do this one. So I have y equals the secant of 1/3 x. Okay, so I didn't mention it before, but surely you've realized by now, it's much easier not to be doing this on paper that's already been labeled with pi and 2 pi because I'm going to be in charge of the scale. I only did that for the parent functions to make that easier. Okay, so my period is 2 pi over b, which is 1/3, and 2 pi over 1/3 is 6 pi. So 4 tick marks, I'm going to label it 6 pi. Halfway is 3 pi. Add them together to get 9 pi. Opposite, negative 3 pi. Okay. My a value is 1, so I don't have to label anything on my y-axis. Then I'm going to go, okay, secant is 1 over the cosine. So cosine starts at a max. 1, 2, 3, 4, ends at a max. Halfway between is a min. Halfway between max and min are zeros. All right. Then we remember before I connect them, I look and see that I have, going to have asymptotes because I can't have the 0. Wrong one. I need to pause for 1 second because my doorbell ringing. Okay, I'm back, but I haven't drawn my asymptotes yet. So everywhere we have a 0, we have asymptotes. So I'm going to put in my asymptotes. And then I'm going to go back and, nope, actually I want to do this. Draw away from my asymptotes. All right, so we got to think about, sometimes that does that. Not nice. Let's try that again. There we go. Okay, whatever. All right, so what is my domain? Domain is all real numbers. X cannot be, where are my asymptotes? Okay, so this is 0, and that's 3 pi. This, of course, is 3 pi over 2. This is, remember we talked about adding it up, divide by 2. So this is 9 pi over 2. Add up, this is 15 pi over 2. And that's not, the pi's not on top. Pi's got to go on top. Okay, so I'm going to start at that first one because I'm not on 0. So that's 3 pi over 2 plus, how far apart are these? 9 minus 3 is 6, and 6 divided by 2 is 3. So that makes that 3 pi n. My range is, I've got all real numbers, and it's one of those functions, absolute value, because it's going away from, so it's greater than 1. Okay? So that is the secant graph. So let's go talk about the last one we have to talk about is the tangent. So back to my parent. Oh, I just missed it right there. Here we go. So the parent tangent function. All right, so again, tangent is what over what. And I hope you know that that is sine. I don't like the way that came out. Sine over cosine. So if it's sine over cosine, then I'm going to have the asymptotes at the same place that I did with my secant function. Or I can think about, well, that's really, you don't want to think about the key points. You just need to know where those zeros are, where those asymptotes are. Okay? And so with the tangent function, we had them at halfway between the pi's. So this is where we have our asymptotes. So I'm going to go ahead and graph those because that's kind of, and then I'm going to help you understand where the rest of it comes from. So I have an asymptote here, and we actually know how to, we'll know how to label that. Okay, so back to it. Now, what happens halfway between, and I'm going to start with this part right here. What happens halfway between the asymptotes? Well, what is the tangent of 0? Tangent of 0 is 0. And then the other key point that, if you remember, will work for both of these functions, what is the tangent of pi over 4? Well, that's where the sine and the cosine are the same number, so the tangent is 1. So halfway between the 0 and the asymptote, it goes up to 1 and then down to -1. So it's going to do this same thing in between every asymptote, because just like the others that we've been talking about, these are all periodic functions, so they all repeat over a certain period. Okay, now let me go draw these. So it's looking like this, approaching your asymptotes. Yeah, I knew it wasn't going to let me do that. Hold on, come on, work with me here. There you go. I'll come back and put the arrows on it. I just need it to allow me to do this. Looking good. Nope, of course, I spoke too soon. Come on, let me curve. Come on. All right, I'll fix that and I'll come back. Okay, so I have my graphs that go on. He's not behaving, so I'll come back and fix that. All right, so my domain, all right, where are those asymptotes? Pi over 2, same thing we had with the secant function, 3 pi over 2, 5 pi over 2. All right, so it's going to be all real numbers. X cannot be equal to pi over 2 plus pi n. Nope, sorry, I didn't write that correctly. Plus pi n. And my range this time, well, what is the range? The lowest number is -infinity, and the highest number is positive infinity. So my range is -infinity to positive infinity. Now, the next thing is, what is the period? How long does it take for this thing to repeat? Well, hopefully you can tell that it's repeated. It's repeating the same thing. So whether you go from pi over 2 to 3 pi over 2 or negative pi over 2 to positive pi over 2, you should be able to tell me that the period is pi. Okay, so my period is pi. Max, there is no maximum value, there is no minimum value, so my amplitude again is not applicable. Okay, last parent function we have is our cotangent, and our cotangent is cosine over sine. So where is the sine equal to 0? 0 at all those multiples of pi. Okay, so that means that I'm going to go ahead and write this because I just said multiples of pi, so x cannot be pi n. Okay, those are my asymptotes. Oh, poo. Wrong color. These are my asymptotes. And to graph it, oh, we got to talk about what happens. Okay, so what happens here, you've got that same point, pi over 4, 1, but I'm not going to graph that yet. I'm actually going to talk about what happens in between, halfway in between. Well, what is the cotangent of pi over 2? It's 0. I have this same point, pi over 4, 1, pi over 4, 1. So that's right here. So if you can look at this and figure out, it looks a lot like the tangent, but this time it is falling, these graphs, when I graph them. Let's see if it'll let me do this. Okay, so when I graph these, kind of missed my point there, but these graphs, don't do that. Stop it. These graphs are falling. Okay, well, I don't want to hold up, so, okay, I'll fix that later. You got the idea. And what is my range? Again, negative infinity to positive infinity. Period is pi, and the amplitude is not applicable. Okay, so one other thing I want to say about this, and you'll hear me talking about it, and it's a way to help you remember where the asymptotes are on these two graphs, okay? So if you don't understand right now, just be patient. We'll do some examples and you'll see. But basically, what is key to both of these graphs is remembering where these asymptotes are. And over here on the tangent function, the asymptote is always half of your period. And your graph is going to rise. And over here on the cotangent, your asymptote is going to be at your period. At your period, and it's going to fall. So you're going to see as we graph what they are. So let's go do some examples. So a few examples, and then I'll be done. Okay, so the first one is 3 times the tangent of theta. Let's see what I'm in that one. And then I need to eat. These aren't going to come out very well, so I'm probably not going to do them. All right, anyway, tangent of theta. So got to start off with the period. Again, now, this time it's, oh, I didn't fill that in. I'm sorry. Let's go back to that. Come on. Yeah, it went too far. This right here. Okay, so in my tangent function, okay, I still have y equals a times the tangent or cotangent. Amplitude, remember, we don't have an amplitude. So there is none, but the period is pi over b, because as we just saw when we graphed it, the period of your parent tangent function is pi, not 2 pi. So if I'm doing y equals 3 times the tangent of theta, it's pi over 1, which of course is pi, and my a value is 3. So I'm going to label, okay, it's going to look a little different than the parent function because those graphs were already labeled for you. But if you want to stay consistent with how we've done everything else, then go out 4 tick marks, 1, 2, 3, 4, label it your period. Half is pi over 2, add them up to get the last one, and then the opposite over here, okay? And if my a is 3, then I'm going to label this 3 and that negative 3. You're welcome to put more tick marks on there and do it by ones if you want to. Okay, so this is when I said, where are the asymptotes? Because I got to remember that. Well, the asymptotes for the tangent function are half of the period. So if my period is pi, then I don't want that color. Sorry, got to be consistent. If my period is pi, then my asymptote is pi over 2. And the tangent straddles the y-axis. So if one of them is pi over 2, the other one's negative pi over 2. If this were pi over 3, that would be negative pi over 3, because it's going to be half the period, and it's always going to be symmetric around that y-axis. Okay, so back to graphing that. We know that halfway between is a 0, and it rises instead of falls. So if you do it like this, you'll have the 2 cycles that I'm asking you to do, and that other pen wasn't working, so I'm going to use this one to graph these. Yep, CK will appreciate the sound effects. Okay, so okay, what's my domain? Domain is, it's all real numbers. X cannot be, okay, I'm on pi over 2, not at 0, so I got to name that first one, whichever one you want it to be, and then how far apart are they? Pi n. My range is, that one's all real numbers, so that one we're going to say negative infinity to positive infinity. Okay, let's do a cotangent. Cotangent. Again, starting with my period. 2 pi over b, which is 2, equals pi. So I'm going to go out 1, 2, 3, 4, label it pi. Halfway is, aren't y'all yelling at me? It's not 2 pi over 2, but pi over 2, because the parent function period is pi. Okay, over my b, which is 2. So I'm going to go out 4 tick marks, label it pi over 2. Halfway is pi over 4. Add them together and you get 3 pi over 4. And over here is the opposite. So I have that. And cotangent, my a value, what's my a value? A value is 1, so I don't have to relabel it. Now I have to do my asymptotes. And my asymptotes are at the period. So that means my asymptote is at pi over 2. And it's going to be at 0. And then I'm going to go back and halfway between the asymptotes is a 0. And then it falls. So that means when I go halfway this way, I go up. Halfway that way, I go down. 0, it's going to go down. And then up and down. And then, curve it a little bit here in the middle. But then make it approach your asymptotes. They're kind of hard to graph sometimes. Okay, what's my domain? That's 0, pi over 2. The next one actually is going to be pi, which is 2 pi over 2. So I'm hoping y'all can see that those are all multiples of pi over 2. So we have x not equal to pi over 2n. My range goes on forever and ever in both directions. All right, last one. This one is going to be y equals 2 times the tangent of 1/2 theta. So my period is pi over 1/2, which is 2 pi. So 1, 2, 3, 4 tick marks. I'm labeling it 2 pi. Halfway between is pi. Add them up to get 3 pi. And the opposite over here. Then my a value is 2. So I'm going to change my scale. And so, basically what you're doing, y'all, when you find that period and amplitude, that's telling you how to label your x and y axes. So you don't want to start graphing until you've done that. So now I have to draw the asymptotes because I know tangent has asymptotes. And the tangent straddles the y-axis. And that asymptote, first asymptote, is half of my period. So I'm going to have this. And then halfway between the asymptotes is a 0. And the tangent, and actually, if you want to tell you, just in case you don't have any for homework, but be prepared for anything, is that if this were a negative, what would it do to everything? Well, the tangent normally rises, so none of these things would change if that were a negative, except for when I got to that point where I would go up 1, I would be going down 1. So I just did that just to kind of change things up and make sure you would know none of your zeros are going to change, but those max and min values or key points will change. So I just threw it in a loop, made it negative, because people ask me about it. Okay, last thing to talk about, what's the domain and range? All right, so this is pi, and the next one is 3 pi. So that means that my domain, is x not equal to pi plus 2 pi n. So keep in mind, if it's not on 0, you're always going to have some kind of plus in here when you're naming that. The range is all real numbers. And that's all. So hope you enjoyed that. If you have any questions, please feel free to email me or come see me. Thank you very much.